everybody. Today we will discuss the topic linear differential equation with constant coefficients. Actually, some part of this topic is not included in your syllabus. So whatever included we will see in detail. So we start from the general form. What is the general form of linear differential equation with constant coefficients? So that is a naught dn y by dxn plus a1 dn minus 1 y by dx n minus 1 plus a2 dn minus 2 y by dx n minus 2 plus and so on plus an y is equal to capital X. So in terms of notation, this we can write as, this equation we can rewrite as a naught d raised capital D raised to n plus a1 capital D raised to n minus 1 plus a2 capital D raised to n minus 2 plus and so on plus an operated on y is equal to capital X, where capital D means d by dx, d square d2y by dx square, d cube is equal to d cube y by dx cube, and so on. And x, what is x in 1? That is RHS, right hand side. Right hand side is a function of x. Capital X is a function of x. So the solution of this equation 1, that is a linear differential equation with constant coefficient, is divided into two parts. So what are they? So the parts are complementary function plus particular integral. So their short forms are CF and PI. Y is equal to CF plus PI. Y is equal to CF plus PI. So what CF means? CF means complementary function which depends on roots of auxiliary equation. Short form of auxiliary equation is AE. And PI depends on right hand side capital X. So what is auxiliary equation? Auxiliary equation of equation 1 is a naught d raised to n plus a1 d raised to n minus 1 plus and so on plus an is equal to 0. So we give number 2 for this auxiliary equation. Now we have written here CF depends on roots of auxiliary equation. So auxiliary equation is equation number 2. So the nature of the roots of auxiliary equation we now study. So there are 2 or 3 cases for this. Case 1 is roots of auxiliary equation are real and distinct. So say roots of auxiliary equation are alpha 1, alpha 2, alpha 3, dot 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 alpha n. Then CF is C1 is a constant, e raised to alpha 1x plus C2 second constant, e raised to alpha 2x plus C3 e raised to alpha 3x plus and so on plus Cn e raised to alpha nx. Case 2 is the roots are real and equal. So real and equal means again there are sub cases. Subcase A, that is if two roots are equal, that is roots are, say first root is alpha 1, second root is also alpha 1, third root is alpha 3, fourth is alpha 4 and so on, alpha n, the nth root. Then what is CF? CF is C1 plus C2x into e raised to alpha 1x plus C3 e raised to alpha 3x plus C4 e raised to alpha 4x plus Cn e raised to alpha nx. Subcase B of case number 2, that is if 3 roots are equal, that is roots are, say 3 roots, means first root is alpha 1, second is also alpha 1, third is also alpha 1 and the fourth alpha 4, fifth alpha 5, nth alpha n. Then what is CF? CF is C1 plus C2x plus C3x square into e raised to alpha 1x plus c4 e raised to alpha 4x plus and so on plus cn e raised to alpha n x. So if you want to produce subcase C, then if four roots are equal, means roots are alpha 1, alpha 1, alpha 1, alpha 1, then alpha 5, alpha 6 and nth root is alpha n. Then what will be CF? CF is C1 plus C2x plus C3x square plus C4 x raised to 3 into e raised to alpha 1x plus C5 e raised to alpha 5x plus and so on plus Cn e raised to alpha n x and so on. So these are the various subcases of case number 2. Then what is case number 3? Case number 3 is the roots of auxiliary equation are imaginary, but imaginary roots always occur in pairs. So and therefore we assume the roots of auxiliary equation are, say, alpha plus minus I beta. Alpha plus I beta one root, alpha minus I beta second root. Say imaginary roots always occur in pairs and therefore we assume this, where alpha is the real part, beta is the imaginary part. Third root is alpha 3 as usual, fourth is alpha 4, fifth is alpha 5 and so on, and the nth is alpha n. Then what is CF? CF is the real part, e raised to real part into x. Real part is alpha, e raised to alpha x into bracket C1 cos of imaginary part into x plus C2 sin of imaginary part into x plus C3 e raised to alpha 3x as in case number 1 plus C4 e raised to alpha 4x plus C5 e raised to alpha 5x plus and so on plus Cn e raised to alpha n x. Again here we take subcase B, that is a pair of equal imaginary roots, means roots are, say, alpha plus minus I beta, first two roots. Again third and fourth roots are also same, that is alpha plus minus I beta, and therefore this subcase is known as a pair of equal imaginary roots. Fifth root is alpha 5, sixth is alpha 6 and so on, and the nth is alpha n. Then what is CF? CF is e raised to the real part. The real part is from both. The real part is alpha x and into bracket C1 plus C2x cos beta x plus C3 plus C4x sin beta x bracket complete plus from C5 onwards we use case number 1, that is C5 e raised to alpha 5x plus and so on plus Cn e raised to alpha n x. So what we have studied here, our complementary function depends on the nature of the roots of auxiliary equation, and the particular integral that depends on capital X, but the part of particular integral is not included in your syllabus. So whatever theory we have to cover in this topic is whatever I have given all these cases, you have to study and accordingly use it in examples. Thank you once again. Stay home, stay safe, be connected digitally.